Let's start today talking about curve straightening. Suppose you have some data. You graph your dependent variable on the y-axis, your independent variable on your x-axis. And just to highlight that's how that works, the independent variable, or IV, as we will call it, is on the x-axis. That's the way it's done. And the dependent variable, in general, is graphed on the y-axis, or vertical axis. And suppose you do a graph in your data. Your first plot of your data, it's not linear. It's a shape that looks something like this. Some kind of what we would call a power curve. Now we want to basically figure out what power it is to. Second, third power, fourth power. And so what we will do what is called a test plot. And I'm trying to draw an arrow that shows us what that would look like. So you take the data that you know and you manipulate it to change how the graph looks. And there are different ways to do this, but the most basic way to do it would be that you would leave the y values alone and you start to play around with the x values to see if you can do what's called straighten the curve. And as we do so, we can find out, if we can straighten it successfully, we can figure out what the relationship is between the independent and the dependent variables on our graph. So what we do is we try a couple of different things. The test plot that we're going to do right now, and we'll basically label this up here. I'm just going to abbreviate test plot so you can see that. All right? And what we're going to do is we're going to take all the x values, we're going to try different things with them to see if we can straighten the curve to get the relationship. First thing we'll try is we'll take all the x values and we will raise them to the second power or square them, just to see what happens. And if by doing this we are able to straighten the curve, we would get something that looks like this. Okay? And what this would show us is that, okay, the relationship that we see on the first part, right here, is actually it's a quadratic. So a test plot that straightens the curve and we square the independent variable, the x-axis values, confirms that we have a quadratic relationship. Now, there are other kinds of curves that we can do this with. We can use this technique for many different ways. Suppose instead we have a graph that looks like this. And suppose we have a graph that basically, try a different color here. On this graph, we find that we have this shape instead. On the part of the first data, we have something that looks like this. This would be what's called an inverse curve. We will still be graphing the dependent variable as y, the independent variable as x. This kind of curve is called an inverse curve. Okay, it's known as an inverse. And basically we want to try to straighten this curve. And one of the ways to do this would be to, again, leave all the y values alone and play around with the x values. So what we would do is we would leave on this test plot, we would leave the dependent variables, the y values, as is, but we would take all the x values and plot them as reciprocals. And if this were what we know as a simple inverse, where this is what the relationship in fact is. The telltale signs of that on the graph would be that it would straighten the curve like so. And this would show us that we have a simple inverse. And that's the gist of it.